Stereolithography, also called as vat photopolymerization or vat polymerization. So, in this particular technology, what we will see is that the polymer, or I am sorry, the raw material which is in form of a resin is loaded onto the tank that you see here. So, the tank would look something like this that you see. So, the tank, vat, vessel, whatever we want to call it. Now, the resin in the initial stage is a monomer, and once the light hits this monomer, it will convert itself into a polymer. So, this is the physics behind how it works, but let us pay attention to how the process itself works. Now, what you see here is then the tank in which a green color resin is poured, and then you have this particular arm which will move up and down. So, you see this arm and then you have a plate there, right. This plate initially will be submerged in the liquid, and as the print happens, this particular plate will go on moving up. Now, there will be a transparent sheet at the bottom, and the UV laser will come from below and it will hit the sheet and in turn the liquid only where we want to melt the or where we want the resin to solidify. So, it will not go on all places, but only where we want the resin to harden. Now, how does the laser know where the hardening should happen? That is coming from the digital file and the slices that you saw. So, one slice is one layer, and in that layer we would have said, okay, this is where the actual part is or where the support is. So, only where we want part or support, the laser light is going to hit the sheet and in turn the resin, and the resin will harden. Now, once it hardens, this UV light is switched off and then the plate moves up, right, and then the liquid forms again below it, and then again the laser will come and it will hit where we need the solidification. So, again it will move up, again this will solidify, again it will move up. So, this process will keep happening until the final printing is over. So, there are a few variations that I would like to bring to your notice. One of the variation is that right now you are seeing that the plate was at the bottom and that we are moving it upwards as the print happens. It can also happen that the tank is very big and the plate is on the top and it can keep moving down. So, the entire time the part which is getting printed and the plate on which it is attached, all of it are submerged in the resin. This can also happen. So, either the plate can move from bottom to up like you see here, or it could move from top to bottom. So, both things are possible. Now, every process that we will discuss, we will see that there are certain advantages and that there are certain limitations. So, the advantages of this particular process is that you get extremely accurate and extremely smooth finishes on the part that you will use this technology for, and it is also possible to produce transparent looking parts with this particular technology. However, there are some limitations. Since this particular part we are using a polymer which is sensitive to light, right. If you use these parts where it is exposed to sunlight, they will get degraded. That is a disadvantage. Also, you cannot use them in places where there is a lot of heat. the last disadvantage that I would like to mention about this technology is that here what is happening is there is a single beam of laser which is trying to go and harden the polymer, right, or the resin. Since there is only one beam and let us say you want to do like a circular area which is quite big, this laser has to move from one end to another end till the entire circular area is hardened. So, this is not a very fast process, it may take time. Now, every process that we will show you will have an advantage and it will have a disadvantage, but it does not mean any technology is inferior or superior to anything else. Now, if I want like a very small, accurate and good finish part, then I will go for SLA technology. In fact, let us get into seeing how VAT photopolymerization can be applied, what are the different applications, correct. So, this is a very good example where VAT photopolymerization can be used, and over here it is used to make aligners, okay, in an indirect way. So, we do not 3D print the aligners, but we will 3D print the model. You might have seen the ad of Virat Kohli and Anushka Sharma of Toothsy, right, wherein you have invisible aligners which people can use to align their teeth in a better way. So, those aligners will be made through a process called as vacuum casting. So, for that you need a mold, you need the exact shape of your teeth, and on that they will place a sheet and vacuum cast it, and this aligner will take the shape of the mold. So, doctors are preferring to 3D print the mold of the teeth like you see here. Why? Because earlier they used to be made with plaster of Paris, which would break at certain corners and things like that, and then they would have to redo it, or some of the sharp features in the teeth, right, they also may not form properly using that plaster of Paris or cement kind of material that they would use. But in 3D you will get the exact features very accurately, hence the aligner also will be very accurate. So, this is a very big advantage or a very big application area of SLA technology. Another big area is also jewelry. So, wax like material which will melt away at low temperature, right, this can also be 3D printed. So, the pattern used to make the jewelry, this pattern can be 3D printed and it can be very complex, because if somebody is trying to do it, handcraft it in a certain way, it may not be so feasible, but if you 3D print it, the pattern design can be extremely complex, and hence the final jewelry that is getting done also can be very, very complex or interesting. We have also listed down some machine manufacturers who are the people who make machines that work on the principle of SLA, and we have also listed down some materials. Here are some variations of the process. So, like I was saying, in SLA we will use a single beam of a UV light, but in DLP what will happen is we will be using light source which is very similar to our TV screen, let us say. So, you can use like LED light also, wherein pixels will be highlighted and then the entire area can be solidified. So, we will discuss DLP a bit more in detail, but another important aspect of the SLA process that I want to touch upon is that after the 3D printing process, so you saw that machine where the vat is there and then you have a laser beam which is coming and solidifying, right. The curing process is not complete. So, after you get the part from the machine, you have to put it in another small machine called as the curing machine, wherein you will have UV light and then you have to leave the part there for a few minutes or a few hours depending on how big or small the part is, and then the part is completely solid. So, that is an additional process that needs to be done with respect to the particular technology. So, be it SLA or be it DLP, this process has to be followed, right. So, I hope SLA process is clear, and I will now move on to a slight variation of this process, which is the DLP, right. And like I was telling you, this process we can use even a LED light. What I think is worth noticing in the picture over here is, last time you saw that there was just one beam which was trying to go to all the places where solidification was required, but over here you are seeing that the entire area can be lit up, can be exposed to light basically. So, I am going to try and zoom in here to show you that it is very similar to a TV screen that can be used. So, let us say you want to have one circular area that you want solidified, then this circle will be basically projected onto the sheet at the bottom and in turn the resin, and then the entire circular area will be solidified, alright. Hence, this is a much quicker process than the SLA process, and that you will see here in the advantage. It has got more higher printing speed, but this technology also gives us extremely accurate and smooth components. The cost of these printers are also quite low, they are not very expensive when compared to the SLA printer. However, the raw material could be a bit more expensive, and the same disadvantage as that of SLA, wherein we will see that the object, when exposed to sunlight, it will degrade very quickly. Now, we will go on to the other variation, which is called as CDLP. So, DLP is digital light processing, and here we have continuous digital light processing. So, how is it different? We saw that in DLP system what is happening is, you will have the plate and then you will have the laser beam, it will solidify and then the laser stops and then the plate moves up and then again it starts and again it solidifies. So, this movement where you have to give it some time for the plate to move up, peel itself from the layer that is there before and keep moving up. So, you have to give it some time, right. Now, in CDLP process, this is not required. The plate can keep moving continuously upwards, that is the advantage. Now, over here in this picture, I am showing you the second possibility that I had mentioned before, that it is not required that the plate always move upwards, it is possible that the plate can also move downwards. Okay. So, this picture shows you that, and already with DLP we achieved quite good fast print, but now it can be even more faster, and the advantage of having very good accuracy, resolution, surface finish, this will continue to be there. So will the limitation of the exposure to sunlight continue to be there. But yeah, you can get complex geometries as in the SLA and DLP process also, slightly lower mechanical properties again because of the same thing, right. So, this is CDLP process. So, how do they achieve this? How do they achieve this? Now, excuse me, I told you that there is a small sheet or a layer where the light from below is going to fall, correct, and that in turn will fall on the resin. So, that is what was happening in DLP and SLA both. Now, what they have been able to do is they are able to introduce a layer of oxygen between the printed part and that particular sheet on which the light source is falling. So, they are able to do that, and Envision Tech, which is one of the companies that makes the machine for this particular technology, they are able to achieve a flat layer of oxygen, not a bulged layer of oxygen like this, but a very flat layer. So, that is how the CDLP process is able to achieve continuous movement. Now, we will address the topic of support structures. You saw in the previous pictures as well as schematic diagrams about the connection of the part to the plate, correct? And support structures were there in SLA technology, and the same thing I have taken here so that I can explain what support structures are, why they are required, etc. This is a SLA or a DLP part that I have taken as example, and all of these extra pillar like structures or scaffolding like structures that you see here, this is the support structure. Now, you will see here that these support structures are connected to the part in a very weak way. So, there may be something like a teeth which will connect the part and the support. Now, why we make it a very weak connection between the part and the support is because we want to break it. So, in SLA process, the supports that are formed are weak enough to be just broken by hand. Also, you see that it's very flimsy, the support structure, correct? So, very easily we can remove it. However, wherever the supports are removed, there is a possibility that the finish over there may not be very good. Some of the support material may still be left over in the part, and then you may have to do some filing or with sandpaper you may have to rub it a little bit to get rid of that extra material. So, in SLA process, support structures are required, but they are very weak. They are not strong supports. In case the same part had to be 3D printed in metal, then the amount of supports that is required would be much higher or much dense. So, you are already seeing two different types of supports here. The first one over here is more thicker or stronger or denser than what you see in image number 2. So, depending on what is the overhang, what is the material and what is the layer thickness that you are printing with, depending on all these things, what will happen is that the supports will have to be made stronger or weaker. So, there are different types of support structures that are required, right. Now, in case of polymer technology, the supports are required only for structural reasons, because when we try and 3D print above a layer of liquid, then there is a good chance that this layer can form, but also dislodge, correct. So, to give a better strength between the part as well as the plate on which we are printing, these support structures are required. But when we start 3D printing with metal, the support structures are required for thermal reasons also, because the layer which is solidifying is first melted. So, this melted material, when it has to solidify, it has to give away heat, and there has to be a support structure there to thermally to act as a heat sink and take away the heat from the part till the platform. So, in case of metal 3D printing, we will have support structures for both structural and thermal reasons, but usually in case of polymers it is only for structural reasons. Do we need to support all kinds of overhangs? Actually no. So, there is a concept called as critical angle when it comes to support structures. As a thumb rule, it is a very general thumb rule. We say that this particular angle is 45 degrees. Okay. So, in the pictures that you see, if there is a surface which is inclined with respect to the plate at a degree of 45, then we say that this surface does not require support. If the surface is inclined at an angle more than 45 degrees, so let us say for example like this 50 degrees, then also we say that the supports are not required, right. So, 45 degrees with respect to the plate and above, we say that support structures are not required. So, the more vertical a feature becomes, the less support it requires. But from 45 degrees, if the feature starts to have a lesser inclination with respect to the platform like 40, 35, 30 or 25, then support structures are required. So, over here we see a transition. So, 50 degrees, 45 degrees, it is printing pretty well, it is not a problem. It is a bit rough, but that is how the technology works. And then when you come to 40 degrees, you start to see it becomes even more rough. 35 degrees, this surface is even more rough. 30 degrees, you start to see burn marks, and 25, 20 degrees, the feature will not form itself, right. So, what is the solution? What is the solution to this? One of the solution is that you will give support structure under it. So, we can give some support structure under it, so that the heat is taken care of, or the structural rigidity is taken care of, and that it will be printed properly. However, the support structures have to be removed. Another solution to this particular problem or limitation is that when you design the part itself, you design it in such a way that you have no overhangs which are less than 45 degrees. So, if it is a new part that you are designing, then this may be a possibility that you can consider and not have surfaces which are below 45 degrees. Now, on the outside, having support structures may still be okay in a certain way, because we can do some CNC machining, or we can do manual clipping operation to remove these supports. But if these support structures get generated inside a part, correct, let us say a cooling channel for example, like if it is inside a pipe, and this pipe let us say is in a S fashion, then it becomes impossible to remove the supports, right. So, designing to avoid support structures is our best option. If not, let us try to orient the part in such a way. So, in the beginning I told you, right, you saw that one bracket part when we were doing the definition of additive manufacturing, you saw that that part was horizontally kept, correct, the part was horizontally kept, hence all of these features below, they needed support. Now, let us say that I orient it, or I try to print it in a more vertical fashion, correct. So, when I try to do this, then the amount of supports required will reduce only to this particular area, right. So, let us say in design there is nothing I can do, and that particular surface will come, then what I can next try is to orient the part or print it in a slightly different orientation, so that these supports may not be required. All right. So, and the last option of course is to put the support structures itself. This is a metal 3D printed part, and here I hope you are able to make out the support structures very clearly, right. And you are also seeing different types of support structures. So, that I will come to in just a minute, but usually in most cases like in SLA or in metal printing, the material that is being used to 3D print the actual part will be the same material for the support. So, if I am printing my part in titanium, the support structure will also be in titanium. If I am printing my SLA part in, let us say, wax like material, then the support structure will also be in wax like material. Okay. The only exception to this I feel is material extrusion process, which is the next one that we will discuss. Only over there we have an option to do the support structure in a different material and the part in a different material, but usually part and support material are the same, and that is the same over here also. So, over here you are seeing a metal part, and they have tried to orient the part. See, it was quite possible to just put this part flat and print it, right, but they have not done that because there are certain areas where they would like to avoid the support structures. So, if you look at this particular circular feature or this particular circular feature, the inside of it they have avoided the supports, correct. Maybe because they want it in a good accuracy when they in the as printed condition, they do not want to do any machining there, but they are okay to do some machining here to get a final accuracy. One more important thing is in metal 3D printing, we recommend that threads be achieved through the machining process, not the 3D printing process. Okay. So, over here maybe they are okay to machine over here. So, they have oriented this particular part, you know, it is in a very inclined way that this part is being printed for specific reasons of their choice. All right, they want a good finish somewhere or a good accuracy somewhere, or they want to fit as many parts as possible on the plate that we are printing. So, in additive it is not required that only one part be printed. If there is space on the plate that you saw, many parts can be 3D printed. All right. So, maybe they wanted to print many parts, and that is why they chose this orientation. So, once the orientation is decided, then the support structures have been put in place, and some of these I can definitely discuss. One of it over here, what you see, this is the most common kind of support, and this is called as block support, and the outside layer of the support has been made with holes, perforated holes, right, and this is because the support structures that we print in metal, usually we will not make it solid. It will be you know, like a lattice structure or a honeycomb structure you can think of. They are not completely solid. Two reasons for it. One, we try to make it like that because we want to spend less time printing it. If I make the supports completely solid, then the time required to 3D print it and the material required to 3D print it will be more, which means my total part price will go up. So, I do not want to do that. Hence, these kind of hollow supports are good for printing. The second reason why we choose this is because it is easier to remove also, correct. When they are not completely solid, it is easily removable. For example, let us say this support inside this particular hole, you can take a plier like a nose plier and apply some force and it can get removed. You can also use like a mallet and a chisel, and these tree kind of supports also can be removed easily. So, if they are weak, then it is faster to print and faster to remove. So, you save both time and money in printing the support as well as removing the support structure. Now, when I say that okay, those are one of the reasons why we are making these holes or not solid. One more thing that you should remember here is that powder, if we are using powder as the raw material to 3D print, then there is a good chance that the powder will be stuck inside this. So, these holes are required on the support to remove the powder. Same with resin also. In case it is not solid and we are making the support hollow, hollow like this, then there is a very good chance that some resin is trapped inside the support structure. So, to remove these resin, we will have to remove the have these holes. Okay. So, two three reasons why we have holes in these support structures. So, block supports are very commonly used and I told you the advantages, but we can have different kinds of support like this. These are called as tree supports, and over here you are seeing that the support structure has an angle, right. This is because we do not want the support to fall directly on the part, maybe we want to make it fall through this gap onto the platform, because remember wherever the support and the part are joined with each other and then you remove the support, that surface will be little rough. So, if there is an option where I can give it a certain angle and drop that support not on the part, but on the plate, then there is one less surface for us to finish. So, angled supports are also used quite often in complicated geometries like this. These supports I would all put them under the category of something called as weak supports, whereas for certain materials, let us say for titanium example, I would probably make these supports completely solid. So, the range of supports that you will have to consider to get a successful print is from full solid support to very weak supports which can be removed by hands manually. So, this is the range of supports that you have. When to use, why to use is something that is a skill that you will develop as and when you print. But this topic is more important for the metal printing than the polymer printing. However, support structures are applicable to polymer printing also. So, I thought we should introduce the importance of support structures when we discuss the very first technology itself. So, with this I would like to say thank you for spending the time with us to understand the first process SLA as well as a very important concept of additive manufacturing, which is support structures. We will now very quickly get into few other technologies like FFF, MJF and binder jetting technology in the next few sessions. Thank you.